Hello, everyone. My name is Denis Owusu. I'm a health informatics graduate student at Michigan Tech, and I'm here with.
Salas Otute. I'm also a graduate student in the Health Informatics Department.
Now, we are presenting our project on the topic integrating machine learning with real-time electronic health record system for the prognosis and diagnosis of cardiovascular diseases. Now, cardiovascular disease is the leading cause of death, accounting for about 17.9 million annually. Now, of this, over 75% occur in low and middle income countries, highlighting the urgent need for early detection and effective intervention strategies. Our problem statement is that despite the advances in medical technology, the early detection of cardiovascular disease remains challenging due to the complexity and volume of patient data. The traditional diagnostic methods often fail to identify at-risk individuals in time, leading to delay interventions and increased mortality. So we base this on an objective that is to develop and integrate machine learning models with real-time electronic health record system to enhance early detection, diagnosis, and prognosis of cardiovascular diseases. Now, our sample data was from three sources, and that is prevalent heart disease, Framingham has study, which is a long-term cohort study with demographic, medical, and lab data of about 5,000 patients. And the prevalent heart disease had about 303 patients. Then also we use the Mimic 3, which has over 40,000 patients. Now for our methodology, we started with cleaning the data through the data pre-processing by handling missing values and removing outliers. We also did normalization. We did categorical encoding, that is converting categorical variables into numerical format using one-hot encoding. And then also we proceeded to feature engineering, that is by extracting relevant features such as age, blood pressure, cholesterol levels from the data, and then merging all this into one. We selected 4 models to train with our data, and that is logistic regression, random forest, support vector machine, and then neural networks. And with these models, we need to hyper-tune them for better results, and the various parameters were set. Now we evaluated our model using various performance metrics such as accuracy, which measures the overall correctness of the model in predicting both healthy and at-risk patients, and then also precision, which ensures the model correctly identifies patients with cardiovascular disease without over-predicting false positive. And then recall captures the model's ability to detect cardiovascular cases, thereby minimizing misdiagnosis. And then we also evaluated using the area under the curve, that is, evaluate how well and the model distinguish between patients with and without cardiovascular disease across all the thresholds.
Okay, with our model algorithms, with the selected models, we first of all imported the libraries like Pandas, NumPy, Scikit-learn, and Matplotlib. We loaded our datasets from the Mimic 3 datasets, Framingham heart disease, then the Cleveland heart disease datasets. We loaded the datasets and we pre-processed. We handled the missing values and normalization, perform normalization on these datasets as well. We then trained our models and hyperparameter tuned them from the logistic regression, random forest to the neural networks with great search. With our models' performances, each of these models had a higher performance, and logistic regression had an accuracy of 99.2. Random forest had an accuracy of 99. Support vector machine had an accuracy of 98, whilst neural networks also had an accuracy of 98. With area under the curve, logistic regression had area under the curve for 88. Random forest had 87. Support vector machine had area under the curve 77, whilst neural network, which is the least amongst all of them, had 64 as the area under the curve. This is the graphical presentation of our performance matrices for our models. In discussion, logistic regression had the accuracy of 99.21 and random forest had 99%. These two models were the best performing models amongst all of the models that we picked, and support vector machine showed a good precision and recall, but had a very low area under the curve. While neural network also had a highest recall, indicating the model's exceptional sensitivity, but its lower area under the curve suggested challenges in distinguishing between classes. With our challenges, we also encountered data quality, how we handle the missing values, and also model interpretability, because with ensemble methods, we need explainable AIs which will aid the health workers understand how our models make predictions. In conclusion, the project demonstrated the potential of integrating machine learning with real-time electronic health record system for diagnosing and prognosis of cardiovascular diseases. The models showed promising performance with logistic regression and random forest, offering the best results in terms of accuracy and precision. In our future works, we think about clinical deployments, how we deploy our models to health facilities to use it and aid in clinical decision. Also introduce the explainable AI such as Sharp and Line to help explain how and why a model made prediction to assist health providers in clinical decision making. Also ensure our models interoperability. These are our references, and thank you very much.
So for any question, comment, or contribution, we can be read through our various GitHub links,
Yeah.
which we shared. Thank you.
Thank you.